Hi everyone, my name is Pen Wang from the OceanBase global team. Over the past years, we've been working closely with users who are deploying OceanBase in Kubernetes, often across multiple clusters, availability zones, and even cloud providers. And along the way, we faced the big question: how do you keep a distributed database stable and high availability, not just in one cluster, but across many? That's exactly what I'm going to share with you today. Before we dive into how OceanBase achieves unstoppable stability through multiple cluster Kubernetes deployment, let's first give you a quick look at who we are and the kind of real-world demands our system is built to handle. OceanBase is a distributed database founded in 2010. We have spent over 15 years optimizing for high performance and high availability. Today, we have more than 1,000 employees and serve over 2,000 customers worldwide, across industries like fintech, e-commerce, telecom, and manufacturing. Some of our global customers include Starbucks, McDonald's, Alipay, GoTo, and HSBC, all trusting OceanBase to power their mission-critical systems. OceanBase is a fully distributed database with built-in scalability and high availability. Data is automatically partitioned, and the system can scale in and out with auto-load balancing, so it adapts easily to changing workloads. We are designed for disaster recovery, whether it's a node, a data center, or even an entire city. OceanBase can recover with zero data loss. Maintenance is also seamless. You can upgrade servers or databases with zero downtime, thanks to proactive traffic switchover. This architecture is what makes OceanBase ideal for multi-cluster Kubernetes deployment, which we will get into next. Stability and scalability are important, but OceanBase is also fast. In benchmark tests across a wide range of workloads, point selects, read-only, read-write, insert-heavy, and update non-index, OceanBase outperforms other NewSQL databases by 3 to 15 times. This isn't just the peak speed. It's consistent performance across real-world scenarios. This performance, combined with zero downtime and a strong consistency, makes OceanBase a solid choice for mission-critical systems at scale. Today, we are in a time of rapid change. Businesses are looking for efficiency, scalability, and agility more than ever. One major shift we are seeing is the widespread move to cloud-native technologies. Kubernetes has become the de facto standard for deploying and managing modern applications. By embracing this trend, we are making sure OceanBase aligns with the broader ecosystem, which means better integration, smoother operations, and more flexibility. But there is another big reason: complexity. OceanBase is a distributed database system, and managing it manually can be incredibly difficult. For many users, it's a huge operational burden. By leveraging Kubernetes, we get powerful tools for automating deployment, scaling, and day-to-day management. This reduces the load on DevOps teams and allows them to focus on more strategic work instead of firefighting. And of course, we can't forget about cost. Cloud-native technologies help us optimize resource usage. With OceanBase, you can scale in and out based on actual workloads, which leads to much better cost efficiency. In short, adopting cloud-native technologies is not just a trend. It's a strategic choice that brings real, measurable value in performance, manageability, and cost. Let's face it, depending on a single Kubernetes cluster is risky. Relying on a single Kubernetes cluster may seem convenient, but it comes with serious risks. It's a single point of failure. Any outage could bring down your entire database. It also makes upgrades risky, since everything happens in one place with no safety net. And it creates high maintenance pressure. Your team has to manage everything in one cluster from storage to failover. That's why we started looking at multi-cluster deployments. Let's look at why multi-cluster makes sense. First, it enables true high availability. Your database can survive even if an entire cluster goes down. It improves disaster recovery and helps you avoid regional failures, especially in multi-availability zone or multi-cloud environments. It also supports smooth Kubernetes upgrades since clusters can be updated independently, and in the long run, it lays the foundation for hybrid cloud architecture, giving more flexibility and resilience. That's why we designed OceanBase to run natively across multiple Kubernetes clusters. To manage OceanBase clusters in Kubernetes, we have developed a dedicated operator. It uses a set of custom resources that aligns closely with OceanBase's internal architecture. At the top, there is OB cluster, which manages the entire system. Then we have OB zone, which represents a zone holding one replica of the data. And finally, OB server, which manages the pods, storage, and services for each data node. The operator takes care of syncing changes across resources and making sure everything stays in sync at the Kubernetes level. The second key component of our operator is the controller manager. For every custom resource, there is a corresponding controller watching for changes. We have defined a common interface called resource manager. It's standardized how we handle the resource's entire lifecycle. Each type of resource implements this interface. The most important function is the one that reacts to changes. When a resource gets modified, the resource manager determines what kind of operation needs to happen next. For each operation, we've defined a task flow, basically a sequence of steps that need to run. These tasks are submitted to a task manager and then executed asynchronously by work pool. Once the task flow completes successfully, the resource status is updated back to running. The tasks themselves are kept simple. For higher level resources, tasks usually just trigger updates on the lower level resources. With this mechanism, we've implemented full lifecycle operations for OceanBase clusters and related resources. Things like creating clusters, scaling in and out, upgrading, and even auto-healing in case of failures. For more complex scenarios, like switch over or failover between master and slave tenants, we introduced the special auxiliary resources such as tenant operation. This define multi-resources operations so we can coordinate changes across several components in one go. When deploying OceanBase across multiple Kubernetes clusters, a common approach is to distribute OB zones across these clusters. But here is the key. We don't need to define OB zone resources in every cluster. Instead, we only create the actual Kubernetes resources like pods, service, and PVCs for the OB server nodes in the remote cluster. All custom resources such as OB cluster, OB zone, and OB server are still managed centrally in a single control cluster. We refer to the Kubernetes cluster running the OB operator as the master cluster, and the other cluster that hosts the actual OceanBase workloads as worker cluster. To make this multi-cluster setup work, we introduced a new custom resource called Kubernetes cluster. It stores the credentials for accessing the remote worker clusters. Then, in the OB zone configuration, we simply specify which cluster each zone should run in. The rest is straightforward. The OB server controller uses the credentials from the Kubernetes cluster to manage resources, pods, PVCs, and services in the corresponding worker cluster. One of the main reasons we designed it this way is simplicity. By keeping a global view of all custom resources in a single controller plane, we avoid the complexity of distributing metadata like OB cluster, OB zone, and OB server across multiple Kubernetes clusters. Otherwise, we would have to run separate controller instances in each cluster and make them work together, which adds a lot of overhead. Having this global view also simplifies service discovery. For example, when we use Prometheus to scale metrics from OceanBase, we can just expose a simple API that queries all OB server custom resources and retains their addresses, because everything is already centralized in the master cluster. This makes implementation and maintenance much easier. Another reason is compatibility and flexibility. In the worker cluster, we only run native Kubernetes resources like pods, PVCs, and services. There is no need to install the OceanBase operator or any custom resource definition in these clusters. The only requirement is network connectivity between the pods and services. Now, what about the availability of the master cluster? Well, the master cluster is only responsible for running the controller manager and managing the custom resources. It doesn't run any business-critical workloads. In fact, you could run the entire OceanBase database in the worker cluster, and even if the master cluster goes down, your OceanBase workloads would continue to run just fine. Also, since the control plane isn't a long-running workload, it's easy to back up and restore. So, maintaining and upgrading the master cluster is low risk. We just need to back up the custom resource and proceed with confidence. This deployment approach was originally inspired by one of our customers. They had already built a multi-cluster architecture for their applications, spanning Kubernetes cluster across multiple cloud providers. Once their application side was ready, they turned to us with a new requirement: deploying OceanBase across multiple Kubernetes clusters as well. Their goal was to achieve extreme levels of availability, not just across availability zones, but even across entire cloud providers. They wanted to ensure the database layer could tolerate outage at the cloud platform level. And this isn't just an edge case. In more typical high availability setups, it's common to run services across multiple availability zones. In this case, you can deploy a Kubernetes cluster in each availability zone and assign one OB zone to each cluster, providing isolation, resiliency, and fault tolerance at the infrastructure level. To wrap up, multi-cluster deployment of OceanBase on Kubernetes gives you stability, scalability, and the simplicity. It's a clean and cloud-native design that battle-tests in production. If you are interested, feel free to catch me after this talk. We'd love to hear your story. Thank you, that's all.